Hello and welcome to this tutorial, and today I will be showing you how to set up a basic STM32 project in STM32 IDE. So the first thing we will do is we'll go to File and create a new STM32 project. Then we'll allow the IDE to download the keep finder database files. All right. All right, so now once that is done, the next thing we need to do is we need to type in the part number of the MCU that we want to use. So in my case, okay, I was typing it in the wrong place. So you type it in this dialog and select which microcontroller we want to use. But for this tutorial, we'll be using the STM32F401 microcontroller. So these two only differ by the package type. So it doesn't matter what package they will be using. We won't be looking into that for now. Then we'll go here and type next. Then the next thing is we will wait first to type in the project name. So for this project, I will type in STM32 demos. Okay. And this project will be of C type, and we'll use the default destination and we'll click finish. And as you can see, the IDE automatically starts loading the STM32 Cube IDE code generator for us. The code generator is integrated into the IDE. Okay, so for the basic setup, so we will only be setting up the clock. We will start by setting up the clock. So for the clock, we need to go to the RCC and enable a ceramic or external crystal resonator. And then maybe just for interest, you could also enable the low speed external clock as well. So now we need to configure our clock. So for our high speed external clock, we will be okay. You can set this to whatever clock frequency, whatever you need to set this to whatever clock oscillator or crystal oscillator you have. So in my case, I will set this to 20 megahertz. And then now we want to use the PLL clock actually. So we will here we'll go. So here we will select the high speed external clock, and then here we also want to use the external clock. Make sure that you selected PLL. You can start with the then go over and select the PLL clock over there. And then for the actual clock that we want to use now, we can type in 120 sorts of range. Okay. Let's see if the clock. Okay, let's see where the problem is. Let me pause the video. Okay, so the problem was it was using the high-speed internal clock, so we're not using that. So we want to use the high-speed external clock at 20 megahertz. Okay. So, and then what is the final clock that's coming? I can actually go on and set the values manually over here, but we won't be doing that. So, okay. So in order to get 100 or okay, the maximum clock is 84 megahertz. So I'm actually surprised why the ID even suggested 120 megahertz. Okay. So and then so let's just give it time to try the resolve required clock. Alright, so it's finally actually finished setting the clock to 80 megahertz using the high speed external and the PLL clock. And then now we need to set the external low speed external clock. Okay. So generally would have to enable the real-time clock in most of the times for it to be activated actually. Okay, so now we've activated the clock source for the real-time clock. And we want to use an external clock. So generally you set this clock to about 32.768 kilohertz. and then all your clocks are ready and done. So that is basically how you set up a basic project in STM32 IDE. And then you can go into the system and set up your debug and set up your clock source or time-based source. I generally set this to time I want to avoid any errors. So then that's basically it. And then you generate your code. All right. And then this is your code which has been generated. This is the main file, and then now you can build the project and all right, everything looks fine.